Hello and welcome back to Ganesh Institute and in this series of linear algebra. So what is there for today? We are going to talk about homogeneous system of linear equation where we will see how we can solve a set of linear equation in the form of ax equals 0 using trivial and non-trivial solutions. So let's get started.
What is a homogeneous set of linear equation or the system of linear equation? So if I have, for example, a1x, b1y, c1 equals 0, a2x, b2y, c2 equals 0, and a3x plus b3y plus c3 equals 0, this will be considered as a system of homogeneous linear equation. Why? Because it is of the form ax equals b. Here A is the coefficient matrix, X is a column matrix, and B is nothing but 0, a 0 matrix. So we say that it is a set of homogeneous linear equation because Ax equals 0. Now, how do we find out the coefficient matrix? By making a matrix of, we can have more variables, C1z, C3z, and so on. So if I collectively take all these coefficients, here the coefficient of x is a1, here b1, here the coefficient of z is c1, coefficient of x is a2, coefficient of y is b2, and coefficient of z is c2. So I am clubbing them together to make a coefficient matrix which will be a1, b1, c1, a2, b2, c2, and a3, b3, c3. Now when it comes to column matrix, it is the matrix of variables. How many variables are there? X, Y, Z. So just make a column matrix out of it. So X would be X, Y, Z. If AX is 0, then we say that these the system having these set of linear equations is homogeneous. Now how would we solve it? How do we calculate whether it has infinitely many solutions or unique solutions? Whenever it has unique solution, that is only one solution, also called as trivial solution. Okay, this is R. Trivial, trivial solution. Whenever there is, if we find out the determinant of coefficient matrix and it is not equal to 0, then it is we can say that the system of equation is having unique solution. And if we have to find out infinitely many solutions, when can we say that equation is having infinitely many solutions? So whenever we have determinant as 0, okay, then we say that it is having infinitely many solutions. Now one more thing which you need to know, because we have already talked about rank, so we would see that how, apart from this determinant concept, we can say that the equation is having trivial or infinitely many solutions. Let's say if you find out rank of the coefficient matrix and it comes out as the number of variables. How many variables are here? 3. And let's say rank also comes out as 3. You know how to find rank? You can watch my previous videos to understand it. Now if rank is equals to n, then we can say that the system has only unique solution, trivial solution. And if the rank is less than Why this pen is not working here? Okay, rank is less than number of variables, then the non-trivial, many solutions. Okay, let's figure this out using an example. For instance, the easiest example I'm taking, x plus y plus z equals 0, y minus z equals 0, and x plus 2y equals 0. Can you tell me what is the coefficient matrix here? Coefficient of x is 1, coefficient of y is 1, coefficient of z is 1. Here is no x, so I can write 0x, right? 0x. So it will be 0, coefficient of y is 1, coefficient of z is minus 1. And then we have coefficient of x is 1, coefficient of y is 2, coefficient of z is 0. What is column matrix? Set of variables x, y, z in column form. So it is in the form of ax equals 0, system of homogeneous equation, linear equation. So let's apply the concept of determinant and find out whether it will be having trivial or non-trivial solutions. A determinant. You know how to find determinant? It will be 1, then hide first row, first column. 0 times 1, 0. And then minus 2 times minus 1 is plus 2. Minus, and we will consider 1. And we will hide this column and this row. We will be having 0 minus minus 1, that is plus 1. Plus 1. And then plus 1, hide this column and this row, so minus 1. So 2 ones are 2, minus 1, that is 0. If determinant is 0, what we say? System of equation has non-trivial or infinitely many solutions. So this equation will be having infinitely many solutions. I'll tell you how we can say that infinitely many solutions are there, or we can say it will be having non-trivial solutions. Non-trivial, I is here. Okay. Now if we apply rank of the matrix concept and see whether rank is, because for non-trivial it has to be less than number of variables. We have 3 variables, rank should come out lesser than 3. So let's find out the rank. We have coefficient matrix as 1, 1, 1, 0, 1, minus 1, and what else? 1 to 0. So this is our coefficient matrix. Let's find out the rank. What do we do in order to find out rank? Either we can apply higher order minus formula, or we can apply row elementary or column elementary transformations to make zero rows. So if we have to find out the rank, we will count those rows which are having non-zero elements. Correct? Let's find out rank. So I'm trying to make as many zeros as I can. So let's do it. It has already 0 here. So let's do it with R3. R3 tends to R3 minus R1. It will make it as, okay, I'm not doing anything with R1, 0, 1, minus 1, R2 has to be as it is. Then R3 minus R1. 1 minus 1, 0, 2 minus 1, 1, 0 minus 1, minus 1. Can you see these two are same? So I can subtract them to make 0 row. Oh, this is R3. R3 minus R2 I can do, right? So this will make it as R1 is as it is, R2 is as it is, 0 minus 0 0, 1 minus 1 0, minus 1 plus 1 0. So how many non-zero rows? There are 2 non-zero rows. So rank of the matrix is, it is denoted by row. Row A is 2. Rank of the matrix is 2. And number of variables 3. Because it is lesser, it is satisfying the condition of being non-trivial, of having non-trivial solution, right? So yes, we have checked it using 2 methods. One is determinant, another one is rank. Now the question is, we are saying that this coefficient matrix is having non-trivial, or we can say infinitely many solutions, right? Infinitely. But if I try substitution or elimination method, which we used to do in our 10th standards or 12th standard, what we used to do, if we apply elimination and substitution method, we would see that really we are not getting anywhere. Every equation is equal to 0. And how to solve it? So we can apply this. If we assume that z is a variable, then from second equation y equals z, that is y equals m, and then x is equals to, from third equation, minus 2y, that is minus 2m. So solution set, which is x, y, z, is, what is x? Minus 2m. What is y? M. What is z? M. So can you see, I have the solution in the form of variable itself. So I have infinite values for m. If I put m as 1, I'll get solution set as minus 2 ones are 2, 1, 1. If I substitute m as minus 1, I would get solution as minus 2 times minus 1, 2, minus 1, minus 1, and so on so forth. I can put as many values of m as I want, and I will get the solution set, those many solution sets, right? So this is how we can say that if determinant is 0, our determinant was what? Here determinant was 0. So if determinant is 0, the system of homogeneous equation is having non-trivial or infinitely many solutions. If rank is less than the number of variables, then also non-trivial solutions, and this is how we can find out the solutions. Okay.
If you really like this video, then don't forget to like, share and subscribe our channel. Till my next video, take care of yourself. Bye-bye.